Good morning. I'm going to talk about light pollution and the impact on natural light sources. So very quickly, because I'm sure you all know that perfectly well, what are the different natural light sources in the sky, okay? And obviously, you have the galactic plane. Most of people know it, but not everybody, by the way. And the Milky Way. You have the ecliptic. And in terms of natural light sources, you have the galactic plane light and the zodiacal light that you can see quite well in that picture. Okay, it was taken in South Australia in the outback. And it's a very unique picture because there is no sky glow on the horizon, which is quite unique. Okay, so this is probably one of the darkest places on Earth. And in terms of natural light sources, of course, you have the deep sky objects such as nebulae. And you can see here the Orion Nebula and the part of the Barnard's Loop. And you can see that you cannot see the south part of the loop because of airglow. And you, of course, all know airglow, and you have the typical pattern here with green and orange bands, okay? And typically it outshines the natural nebulae, okay? So, of course, you have the aurora light. I took that picture in Iceland. And last but not least, the moon, okay? So now if we try to position those natural light sources on a scale, we see that we are disrupted by light pollution, okay? And light pollution, I'm not going to give too many details, but it has many impacts, okay? Impacts on biodiversity, and we are uncovering that year after year. There is still a lot of work to do to understand what is the impact of light pollution on biodiversity. It has an impact on human health and also on human culture, okay? Not being able to see the natural light sources, the Milky Way, is something worrying, okay? And if you can see some surveys that show that many young people have never seen the Milky Way, especially in Europe and North America. So when we try to quantify light pollution, we have many different scales. Typically we use the number of stars visible to the naked eye, okay? So it goes from more than 3,000 in very preserved sites, and it's less than 100 or even less in big cities, okay? We use a more a scale which is more directed toward the Milky Way, okay? Is the Milky Way visible to the naked eye? And typically in large cities, it's absolutely invisible. And if you are in a suburban area, you can barely see the Milky Way at the zenith, okay? And if you are in a rural site, you start to see some details. And of course, if you are at the top of Mauna Kea, which I did, okay, you do not even recognize the constellation. There are too many stars, and the Milky Way is absolutely spectacular. So this is a unique experience that I really recommend. And if you can also use unit of brightness compared to a preserved site, okay? If you say that the luminance of the natural sky is 1, typically in a rural sky will be twice as bright as the natural sky. And in an urban area, it will be 10. And in a large city, it will be something like 500, okay? So now, if we try to position natural light sources on the luminance scales, we use typically millicandelas per square meters, okay? So this is really a surface brightness, okay? You can start by positioning the moon, okay? The sky with a full moon and a sky with a partial moon, and you can go up to maybe 20, 30, 40 millicandelas per square meters, okay? And typically the galactic plane is going to be positioned in this area, okay? So of course it's a little bit fuzzy because it depends which part of the Milky Way you're talking about. but it goes basically from 0.25 to 0.6 millicandelas per square meters. Okay, and by the way, I didn't mention that you have the dark natural sky, which is at 0.15. Of course, it's not 0 millicandelas. If you position the deep sky objects, as we have seen in the first picture, okay, and the integrated starlight, you can see that it's very low, below the galactic plane. And the airglow is, clearly has an impact. It can outshine the deep sky objects, as we have seen. And aurora can be extremely bright, okay? We saw in a previous slide that you can read a newspaper with an aurora. It's probably pretty rare, okay? But with the full moon, you can absolutely read a newspaper. I don't because I have bad vision, but you can do it normally. And finally, you have the zodiacal light, as we have seen in the picture, which is pretty low. And you have the Gegenschein, which is probably the most difficult to see, which is similar to zodiacal light, which is a reflection of sunlight on interplanetary dust in the ecliptic plane. And this is in the anti-solar position. So if you're lucky enough, you can see the Gegenschein. So when we talk about light pollution, we are not going to use millicandelas per square meters. We are going to use magnitude per square arc seconds. Okay, so this is the scale on the right. So typically we know perfectly well that in a rural sky, we are going to be above 21.25 magnitude per square arc meter. So this is a reversed logarithmic scales, but it comes from astronomy, okay? And astronomers do always complicated things, okay? So if you are in a rural sky, typically, here is what's going to happen. You are not going to see anymore the zodiacal light. A large part of the galactic light is going to be hidden to you. And if you are in a dense suburban area, basically, all what you're going to be able to see is the moon, okay? So now, how do we measure light pollution? Okay, so we use a device, a photometer, okay, and typically this is one of our devices that we use, which is installed at the VLT in Chile. And as I said, we use magnitude per square arc second, which is what we call the NSB, night sky brightness. And we measure it traditionally at the zenith, okay? So we have a solid angle of 20 degrees. And every minute, over months and years, we are going to record the luminance of the sky at the zenith in magnitude per square arc second. And we are going to process statistically all this data, okay? So what do we get? And so this is typically what we get in Chile, okay? So this is, you have the time, you have the night, okay, on the horizontal axis. And on the vertical axis, you have the NSB, the brightness. So the lower is the darker, okay? So you have the sunset and you have the sunrise and you have a recording. This is a blue curve of the NSB every minute. And you can see that we also put on the plot the galactic latitude of the zenith and the ecliptic latitude of the zenith. This is to evaluate the contribution of the galactic plane and the light in the ecliptic plane also. So what you see is a nice shaped curve. So this is a clear night because this is very smooth. And you can see that there is a very big variation of the NSB along the night. This is a Milky Way passing through the zenith. And here, this is basically the Sagittarius constellation, which is very bright. So this is what we get in a rural site in France. So as you can see, it's very different. Of course, we have Cygnus passing through the zenith in France during summer, but so it's not as bright as Sagittarius, but there is obviously here, as you can see, a dimming of the light of the galactic plane, which is due to light pollution, okay? So you can notice, by the way, that there is an extinction of public lighting. This is typically the kind of drops which are related to the extension of public lighting, which is very well adopted in France. So, of course, in Chile, this is unique. You can get that type of very nice set of curves. Okay, so I have removed the cloudy nights here, but there are very few in Chile, in Atacama. And as you can see, the dance of the Milky Way during 1 year. Okay, and this is spectacular. Okay, so you can see that at the darkest, you can be 22 magnitude per square arc second. And there is more than 1 magnitude when there is a combination of the Milky Way and the ecliptic plane to the brightness of the sky. So this is a unique preserved site, and you cannot see that typically in Europe. Jean Linnenstein took that recording of an aurora in Norway. So this is just to give you an idea of the kind of level that you can get with an aurora. This is extremely bright, okay? So it proves the point that we made at the beginning that aurora, of course, can be extremely bright. And just to finish, we use different tools, okay, using that type of recording of the luminance of the sky at the zenith. So we can design very sophisticated tools to figure out what is the impact of light pollution and what are the natural light sources that we can detect. So typically in that diagram, this is for a rural site, we have the galactic latitude absolute value of the zenith on the horizontal scale and the NSB, the sky brightness, on the vertical scale. And the size of each dot for a portion of night without moon is reflects the presence of cloud, okay? Small dots mean that there is no cloud, this is clear. Big dots means that it's cloudy. And then the color represents the months of the year. And you can see that in this site, when there are clouds, you can be either brighter or darker than a clear sky. This is typical of a rural site because sometimes clouds protect you from light pollution, and some other times clouds reflect the light from nearby cities. And you can see that you can be on either side of those little dots. And the slope of the little dots gives you an indication of the level of light pollution. So as you can see here, it's almost flat. It means that there is some level of light pollution. And then if you go in Chile, you can see that the pattern is completely different. Okay, when there are clouds, typically you are going to have dots at the lower part of the diagram and never above it. What is above with large dots means that probably there was some airglow, typically at the time of the observation. And finally, to conclude, we use also that kind of tools where we take full sky image of the luminance of the sky. So this is an example of a rural site, and you can see on the circle around on the horizon the cities at the origin of the skyglow, typically Lyon and Saint-Étienne, and so on. And you can see the Milky Way is fading, and you cannot see anymore the Milky Way at 30 degrees of elevation. Okay, so this is typical of a rural site where you can see the Milky Way at the zenith, but not at all near the horizon. Okay, so of course, in terms of solutions, we have to do better light control and to enforce regulations, not only for public lighting, but also for private lighting. Thank you for your attention.